Hi everybody, welcome to 2.5, where we're going to look at division with integers. So we have looked at addition, subtraction, multiplication, and now we're going to look at division. And what you're going to learn is that division is related to multiplication. We're going to do the same division that we did in chapter 1 with whole numbers, except now we're going to expand that to work with integers. So whether the numbers are positive or negative, we'll be able to work with them. So let's have a look. So when we divide negative numbers, since we already know about multiplication, it's important to remember that multiplication and division are related. So the correlate for multiplication is that when you multiply two numbers, if they have the same sign, the result will be positive. Well, if you divide two numbers and they have the same sign, then the quotient, the result of division, will be positive. Okay, so that's still true. So if you divide two numbers and they're both positive, the result is positive. If you divide two numbers and they're both negative, the result is positive. So a positive divided by a positive is positive. A negative divided by a negative is positive. It goes in a positive number of times because they have the same sign. If two numbers have different signs, then the quotient, the result of division, will be negative. So if you have a positive divided by a negative, or a negative divided by a positive, one of each in multiplication or division, the result is negative. Remember, we call the quotient the result of division. And you can say the result, the answer, or quotient. They'll all mean the same thing in this context. So let's look at some examples. So here's A. 12 divided by 4. This is a straightforward problem that we could have seen in chapter 1. 12 divided by 4. They're both positive whole numbers. 12 divided by 4 goes in 3 times. Now let's have a look at B, see what happens when one of the values is negative. What's negative 12 divided by 4? Well, if we follow the rules, right, if we're dividing and we have different signs, then the result is going to be negative. 12 divided by 4 is still 3. So negative 12 divided by a positive 4 is negative 3. A couple of ways to remember this. You should be able to take the result of division, the quotient, multiply it by the divisor, and get the dividend. So what's negative 3 times 4? Oh, sure enough, that's negative 12. So this checks out. The math checks out. You should always be able to multiply back to get what you began your division with. So the other way to think about this is, what if I owe $12 and then I divide that up into 4 equal payments? That would be $3 of debt payment every time. And so that's kind of how I can think about this and make sure that it stays related to what I know about the real world. All right, C, positive 12 divided by negative 4. I need the parentheses because I can't have divided by negative right next to each other. I can't have two signs next to each other. Now, I know 12 divided by 4 is 3. So I divide the absolute values of the numbers. 12 divided by 4 is 3. And now I have to pick a sign. One's positive, one's negative, different signs. So I use the difference sign, the minus. All right, last one. D, negative 12 divided by negative 4. I know 12 divided by 4 is 3, and I have to pick a sign. So a negative divided by a negative, the signs are the same in division, I'll get a positive result. So when the signs are the same, the result is positive, these two. And when the signs are different, the result is negative, like these middle two. So hopefully that's connected to multiplication for you. Let's look at another example where instead of writing the problem as division with the division symbol, we're actually going to write a fraction. It's kind of convenient because this is the division symbol, but what you notice is, oh, that's a fraction bar, and there's your numerator, and there's your denominator. Numerator, the number, and then the denominator. Which is the denomination, right? The amount in a whole, the denomination. So the number you have out of how many in a whole, and then the fraction bar is there. So in addition to writing the division symbol, we can write it with a fraction bar. So let's look at this next set of examples. Let's start with A, 20 over 5. Now 20 over 5 means 20 divided by 5. 20 divided by 5 is 4. What about negative 20 divided by 5? Negative 20 over 5 is negative 4. Remember that fraction bar is just division waiting to happen. All right, C. How about 20 over negative 5? The signs are different, and so that means I'm going to end up with the difference sign, and now I can divide the absolute values of the numbers. 20 divided by 5 is 4. And D, negative 20 divided by negative 5. A negative divided by a negative is positive because the signs are the same, and 20 divided by 5 is 4. And so remember that when you're working with fractions, whether the top value, the numerator, is negative, or the bottom value, the denominator, is negative, the fraction will be negative. If you have two negatives, one of each, in both the numerator and the denominator, then that fraction will resolve to be a positive fraction. So if you have one negative sign in a fraction, then the whole fraction will be negative. And if you have two negative signs in a fraction, then the whole fraction will be positive. Let's look at some more examples following the order of operations. So this one here, 10 minus 2 to the third power, and then this is times the absolute value of negative 3 minus 1. I like to draw my absolute value bars a little longer than the book because it's not as clear from handwriting as it is from typed pages. So what do I have to do first? The absolute value of a number is something I would have to resolve before I do anything else. So I'm going to work on going inside the grouping symbols here. So I'm going to try to resolve this, and everything else is going to come down. I'm not going to worry about any of it until I've resolved this. So negative 3 minus 1, I can think about that as negative 3 plus negative 1, right? I can add the opposite, which would get me negative 4. So 10 minus 2 cubed times, and I know this is times because I haven't written a symbol, I haven't seen one, so that's what it means. It means multiplication right there, times the absolute value of negative 4. Now I have to take the absolute value of negative 4 before I can do anything else. The absolute value of negative 4, the absolute value of a number is the number without its sign, so 4. So instead of times the absolute value of negative 4, I could just put in times 4. So that's what I'll do. 10 minus 2 cubed times, and I'll use parentheses just because it's a good habit whenever I'm introducing a value in that I use parentheses until I know what kind of a situation it's in. Now I want to, now that I've done everything inside the grouping symbols, the absolute value bars, I can go after the exponent and evaluate that. So 2 to the third power is 8, so this is going to be 10 minus 8, and it's still times 4 here. Now I'll do the multiplication before the subtraction, so I'll do 8 times 4, and I'll just kind of come over here. So 10, 8 times 4 is 32, and 10 minus 32, I could think of this as 10 plus negative 32 if that helps me. If I have $10 and I try to spend $32, what happens? I'm $22 overdrawn. Great. Let's look at another example here before we move on. Let's evaluate a to the 4th minus 7 over 3, where for a equals negative 2. So what we're going to do is take negative 2, and we're going to substitute it into this expression, and we're going to see what we get. So instead of a, I'm going to write negative 2, and notice I need the parentheses to show what value is substituting for the variable, to the 4th power minus 7 all over 3. Now, negative 2 to the 4th power, the negative is included because I was substituting in for the variable, and the variable is negative 2. So the whole thing has to be included. So this is negative 2 to the 4th power, which is negative 2 times negative 2 times negative 2 times negative 2. So that's 4 times another negative 2. It's negative 8 times another negative 2 is positive 16. So this is going to be 16 minus 7 over 3. 16 minus 7 is 9 over 3. Now I can divide, and it goes in evenly. So it's very important that when I substitute or when I evaluate a variable expression, that I be very careful with parentheses, that I take it step by step. And you can see here it looks like maybe the book forgot to add in the exponent there. So if you're a little lost when trying to follow that example, that's what's going on there. So follow my example and then be in touch if you have any questions. All right, so let's review division with integers. It's actually very similar to multiplication in that if we have the same signs, the result is positive, and if we have different signs, the result is negative. But it's important to remind ourselves of something we looked at earlier, which is that every division sentence or problem can be written as a multiplication problem. So the equivalent multiplication problem to this would be negative 3 times 4 equals negative 12. We can always multiply the quotient times the divisor and get the dividend. B. Write a multiplication problem equivalent to the division problem, negative 12 divided by negative 4 equals 3. Just remind yourself when you're dividing two negatives, it's a positive, because if you were to write the equivalent multiplication problem, you'd still have a true statement. And C, the grand finale here. If two numbers have the same sign, then their quotient will have what sign? Their quotient will have the positive sign. All right, so I hope all that made sense, and please be in touch if you have any questions, and I will see you again in Chapter 3.